Jai Hind everyone. So this is Dr. Avdhesh Gupta, Professor in Department of Computer Science and Engineering at Kumar Garg Engineering College. Today we will discuss the basics of concurrency control and little bit about a deadlock. Okay. So concurrency control. This topic comes in database management system, and concurrency is the topic which comes after serializability. So what is concurrency? Concurrency, it means if we are doing some parallel transaction. So the parallel transaction do not conflict with each other. So these parallel transaction can execute very easily, and it do not harm any type of database existing in our system. So a database must provide a mechanism that will ensure the possible schedules that either the conflict or view serializable or recoverable and preferably cascadeless. What is cascadeless? Cascadeless schedules are those schedules which is if we are cancelling a transaction, it do not affect other transactions also. If we are cancelling a transaction, if it affect all other previous transactions, then it is called cascading schedules. So we are preferring cascadeless schedules. So a policy in which one transaction can execute at a time, generate a serial schedule, but provide a pure degree of concurrency, because if we are doing a serial transaction, it means we are not using the power of CPU. CPU can process multiple transactions at a time. So what we have to do? We have to do we need to provide multiple transaction to the CPU, so that CPU can execute multiple transaction at a time. So this is a degree of concurrency. It means the computer can process multiple transactions at a time, but it ensure that consistency, durability, and other properties of transaction will be there. Testing a schedule for serializability. After it executes, it's a little too late. The basic goal is to develop concurrency control protocol that will assure serializability. And what is serializability? Serializability is a non-serial schedule that gives the output as the serial schedules gives you the output. The output will remain same, serializable and serial schedule. But the serializability is parallel transaction. It means if we are doing some parallel transaction, but the output will remain same as a serial transaction output. Okay. What are the weak levels of concurrency? Weak level of consistency. Some applications that are willing to live with weak level of consistency allow schedules that are not serializable. And the trade-off, accuracy for performances. Lock-based protocol. Basically, these are the protocol which we apply for concurrent transactions. There are two modes. One is exclusive mode, and another is share mode. Exclusive mode is what where the transaction is logged for the write operation. In exclusive mode, the data item can be both read as well as written, but exclusive lock is requested using lock X instruction just because of it apply the write operation. First it read and then it write. But in shared mode, that item can be read only. The write operation is not feasible in the shared mode. So S lock, it means shared lock, is requested using a lock S instructions. Lock requests are made, concurrency control managers and transaction can proceed only after request is granted. Once the request is granted either for the exclusive mode or shared mode, then only the CPU will handle these type of locks according to their permission. If the lock is exclusive, then it gives the permission to modify the record, and if the permission is granted for shared mode, then the transaction or the database is in read mode only. No one can allow to edit the record. Lock compatibility matrix. What is this? This is what if there are parallel transactions, if there are concurrent transactions, then if one applied shared lock on some transaction, then another transaction can do the read operation only. Another transaction cannot apply exclusive. If one transaction is in exclusive mode, then shared mode is not possible. because it is an exclusive. It means this particular transaction, this particular operation want to do write operation. If this is a write operation, then no other transaction can be allowed for either shared or exclusive. Then it is false, false. The true, it means if there are two transactions, two operations on a same transaction, on a same data set, so shared log can be applied by these two operations, but exclusive mode only one can allow, other are not allowed. A transaction may be granted a lock on an item if the requested lock is compatible with the locks already held on the item by other transactions. Any number of transactions can hold a shared lock on any item. On a shared lock, any number of transactions, any number of operations we can apply. But exclusive, only one. So, but if any transaction hold an exclusive mode on an item, no other transaction may hold any other lock. Shared or exclusive, no lock can be granted if one transaction can hold exclusive lock. So this is an example, schedule with lock grants. So this is a schedule, okay. So lock XB, it means on a variable B, the system allow exclusive lock. The system allow exclusive lock. It means the T1 transaction can do the write operation on the variable B. So what does it mean? The concurrency control manager apply the grant X. It means it allow the transaction T1 to do some write operation on B. So it allow grant X exclusive lock on a variable B in transaction T1. So it read the variable B, it changes the value of B, write B, and then unlock B. What is this unlock B? Unlock B, it means we are leaving the locks on the data item B. Leaving the lock. It means the exclusive lock has been released. Now next, lock SA, shared lock on data variable A. So it means granted shared lock on a data item A in transaction T2. T2 transaction has requested that it can apply shared lock on variable A. So it read A, unlock A, and then lock S. Unlock A, it release the shared lock on data item A, and also it requested to apply shared lock on a data item B. Listen, this is already requested that unlock B. So this lock SB. Then read B, because it already granted S, then read B, unlock B, and display A plus B. It read the data item changed by this one because it already released it. Then lock XA, display the data item A plus B. Suppose let's say the value of B is let's say 70. Value of A, let's say, is 80. So in the first operation, when we are we are modifying the value of B, then it is B minus 50, it means 20. The final value of B is 20, and in this mode A is 70 only, and it display the A plus B, so it means 80 plus 20, it means 100. So it will display the value of A plus B, then 80 plus 20. Then again lock exclusive lock on variable A by the transaction T1. Then it read A and it modify the value of A, then write A and then unlock B. Okay. Then final value of A should be 80 plus 50, it means 130. So it will display 80 plus 20, 100, but the final value of A should be 130. Okay. So this is how that some transaction can apply some lock, different type of lock X and lock S, share lock X, release, unrelease, release and applied. So these are the some example with some types of locks. Okay. This schedule is not serializable. Not serializable. Why? It is not serializable. The main concern is that what I have said, the output should remain same. If T2 display A plus B, the output will be 100. But Transaction T1 change the value of A also. Change the value of A. What is the current value of A is 130. Then it should display 130 plus B, 20, 150. 150 should be the answer. So this is not serializable. A locking protocol is a set of rules followed by the all transaction while requesting and releasing the lock. Locking protocol ensure that enforces serializability by restricting the set of possible schedules. What is the possible schedule? What we can do? We can apply that this particular display A plus B should be after the releasing every type of locks. And there is no other transaction requested for exclusive lock on either variable A or variable B. Then only it will display the final value of A plus B. Okay. So this, if this happens, if this display after the all exclusive lock and shared lock, then this can be a serializable schedule. What is deadlock? Consider that this is a partial schedule. This apply exclusive lock on data item B and this apply shared lock on data item A. Okay. This do not release write B, but it do not release. Again, it exclusive lock on A, lock S, read S on A. What happened? T3 and T3 do not finish any operation and T4 start. T4 do not finish any operation. It means it do not unlock any variable, but it apply exclusive lock. So T3 and T4 both are waiting each other to release any lock. So T3 not T4 can make progress executing lock S on B causes T4 to wait for transaction T3 to release its lock while executing exclusive lock on variable A. It causes T3 to wait for T4 to release a lock on A. So releasing a lock after granting any lock, shared lock or exclusive lock, releasing a lock is a must. Such a situation when the T3 is waiting for T4 and T4 is waiting for T3. Such a situation is called a deadlock. So to handle these type of deadlock, either T3 or T4 can be cancelled or can be rolled back so that the lock can be released. If T3 released all lock, T4 transaction can be successfully executed. If the lock in T4 transaction can be rolled back, then T3 transaction can be successfully executed. Okay. So the potential for deadlock exists in most locking protocol. Deadlocks are a necessary evil. We should always allow, we should always motivate, we should always consider that any other transaction should be deadlock free. Because if there is a deadlock, then the time taken in the transaction completion will become more. Starvation. What is a starvation? You have already studied starvation in operating system. Because in operating system, there are several transactions, there are several operations that are concurrent on serial transaction. In DBMS also, there are some concurrent or serial transactions that we should consider should be deadlock free. So starvation is a concept of operating system, but it comes in DBMS also. So starvation is possible if concurrency control manager is badly designed. What is a starvation? Starvation is a situation when the deadlock cannot be released if the time taken is too long and it cannot be released. A transaction may be waiting for exclusive lock for a data item, while a sequence of other transactions requested and granted a shared lock on the same item. The shared cannot be the shared is not unlocked. So if I am applying a shared lock on any data item, the other has to wait for infinite time. It cannot apply, it cannot be granted exclusive lock on that particular data item because I or other transaction can already hold the shared lock on the same data item. So concurrency control manager can be designed to prevent this starvation situation. So if we are applying shared lock also, then it should be unlocked immediately after reading the transaction or after completing its operations. The two-phase locking protocol. What is two-phase? Obviously, the shared and in read mode, shared or in exclusive mode. There are two phases. One is growing phase. when the transaction is granted. If the user is requesting to allow shared mode exclusive lock, it means we are requesting that lock has not been granted. Once the lock has been granted, the operation will complete its operation, complete the transaction. Then it requests to release the lock. Then the phase 2 started, shrinking phase. So in growing phase, transaction may obtain locks. Transaction may not release lock in growing phase. But in shrinking phase, the transaction may release lock but may not obtain any lock. So growing phase is the phase where we can obtain some locks, either exclusive or shared mode. And shrinking phase is what? In shrinking phase, we are not obtaining any type of lock. We just release the locks. This protocol assured serializability. It can be proved that the transaction can be serializable in order to their locks. Okay. So this phenomena, this is called growing phase. This is the time duration where the transaction can take its time, and this is the shrinking phase where the locks has been released. Okay. The two-phase locking protocol does not ensure freedom from the deadlock. There may be deadlock. Extension of two-phase locking protocol is these two. These two are most important because we must know that the difference between strict two-phase locking and a rigorous two-phase locking protocol. The two-phase locking protocol is just a growing and shrinking phase. In growing and shrinking phase, these are the phases of two-phase locking protocol. And the extension of two-phase locking protocol is strict two-phase and a rigorous two-phase. If I am asking what are the different types of locking? Two-phase, strict two-phase and rigorous two-phase. So what is a strict phase? A transaction must hold all its exclusive lock till it commits or abort. In a rigorous two-phase, must hold all locks till commit and abort. What is the difference between these two transactions? Holds its exclusive locks. And in this, all locks. This is the basic difference. Strict, it means we must hold exclusive locks only by the commit or abort. But in rigorous, we must hold all types of lock. Either the transaction is in shared mode. We must hold all types of locks until it's commit or abort. So this is rigorous and this is strict. So rigorous is, we should avoid rigorous. We should avoid, because if any operation is in shared mode, the other person or other user can read the transaction at the same time. So transaction can be serializable in this order in which they commit, and it ensured a recoverability and avoid cascading rollback. So strict two-phase locking protocol, we must follow the strict two-phase locking protocol rather than rigorous two-phase locking protocol. So most database implement rigorous two-phase locking protocol, but refer to its simply two-phase locking protocol. Many of the databases follow rigorous two-phase just because of the condition to database that it must release all types of lock, either it is in shared mode. If I'm holding the exclusive lock only, shared mode, it is not considered in the strict two-phase locking protocol. But in rigorous, all types of locks has been granted and all types of lock has been released so that other transaction can apply the lock. But strict two-phase locking protocol is very simple because we just allow only write operation. But in larger transaction where there are a huge amount of databases there, then a rigorous two-phase locking protocol is better. Okay. So this is another example where two-phase locking protocol is not necessary condition for serializability. And in order to absence of extra information, the two-phase locking is necessary for contract sensing in the following senses like this. So this is a lock X, this is a lock S, exclusive lock on data item B, unlock B. Then shared lock on data item A, unlock A. Then shared lock on data item B, unlock B, then display A plus B. Then exclusive lock this, then A changes, then write A, unlock A. So this is a transaction. It means T1 and T2. These are conflict serializable schedule, but they can not be obtained if their two-phase locking protocol can be used. So we should always consider that the transaction must release the lock. The transaction can be completed if the final answer should be remain same. Locking protocol, such as two-phase locking protocol. A schedule S is illegal under a locking protocol if it can be generated by a set of transactions that follow the protocol. A protocol ensures serializability if all legal schedules under the protocol are serializable. The strict two-phase locking protocol, more about something, some points in strict two-phase locking protocol. Here a transaction that must hold all exclusive lock till its commit abort, and regress. All locks are held till commit and abort. Okay. These are the lock conversion. What is the lock conversion? If the shared lock has been granted to a data item A, so it can be converted into a exclusive lock. Because first, if we want to read the data item, let's say if I read the banking balance that it below 1000, then what should we do? We do some exclusive transaction. We should add the money to this bank just to avoid any financial charges. So shared mode can be converted into exclusive mode, and in the same phase, the exclusive lock can be converted into shared. Let's see. In the growing phase, can acquire a shared. First, we will apply the shared lock and lock S has been granted. Then can acquire exclusive lock. After that, it can also acquire the exclusive lock. And then convert in this, the shared lock can be converted to an exclusive lock. It means upgrading the lock. And what is downgrading? Shrinking. Can release the shared lock. Can release the X. Releasing. It means the lock X to a shared lock, because shared lock granted first, then exclusive lock granted. So releasing the exclusive lock, then releasing the shared lock. It is a downgrading. Okay. So these are the conversion. So this protocol ensures serializability because we must lock the data item in shared, then exclusive, then releases in the same way. Exclusive lock first release, then the shared lock release. This is the automatic acquisition of locks. There are some scripts that can allow to apply the lock automatically on some data item. Okay, you can read the algorithm because it is the same as the converting a lock. So implementing of locking, a lock can be implemented as a separate process. Few students or most of you read that there are in serializability there is no locking protocol exist. So what do you think? Do you think that the locking protocol, the protocol which we are applying manually, or locking protocol is read separately or applied separately? Yes. The lock manager can implement it as a separate process. If you are not applying any type of these locking mechanism, then what is the condition? Either the database itself consider the locking protocol, or you should always avoid this locking protocol if there are some serial transaction, or the serial transaction can be simplified into a concurrent schedule. This is very simple. Otherwise, in all other transactions, the locking protocol is necessary. So transaction can send lock and unlock request as the messages, and lock manager reply to the lock request by sending a lock. Like for example, if we are inserting a debit card into a machine, the machine we can simply read the amount from our account, or we can withdraw the amount. So the machine think that you are applying the read operation first. If we are asking to withdraw some money, then we press a button, withdraw, then it sends a message that the user is requesting for the exclusive mode. Then it convert the shared log into exclusive mode. So this is automatic process, but as a programmer, we should write the script according to the operations. Okay. So this is an example log table. This dark rectangle T3, T23, T1, T8 indicate granted locks, and light colored indicate the waiting request. So this I7, I23, these are in waiting state, and these are in waiting state T2, T23, ye waiting, and this is already granted. Okay. So log table also record the type of locks granted. New request is added to the end of the queue request for the data item. It means T2 has been added to the end of the request, so that this has been given the less preferences, because if once the transaction has been apply or granted the lock, then the next transaction T2 is a new transaction, then we apply a granted lock in after these transaction complete its operations. Okay. So unlocking request result the request being deleted, and later requests are checked to see that they can now be granted. Okay. If transactions about all waiting or granted, then request of transaction are deleted. Log manager may keep the list of logs held by the transaction, each transaction, to implement this efficiency. Okay. So this is a log table. We can implement this log table very easily. Okay. Next is graph based. So this is another topic in concurrency control, graph based, tree based protocol. So what is graph based protocol and tree based protocol? This is basically another approach of two-phase locking protocol in concurrency control. So graph based protocol are quite much faster as compared to two-phase locking protocol. Okay. So this is basically a very simple and very easy protocol. If we talk about the tree protocol, then only exclusive locks are allowed. First, the lock applied on A, then B, then D, then G and H and J operation. So it is in very simple way graphically representation. So in concurrency control, if we write the transaction in T1, T2, T3 column, it is very tough to manage or tough to read the transaction. But what happened in the distributed database, in the larger database, if the data item is A has two parts, B and C, and if we want to apply the lock on E, so what should come? If we apply data item E, then B and A must be in a right phase, but other can be, we can skip any type of lock on these data items. So this is very simple protocol. So that's enough for today. And in next classes, we will discuss more about this graph based tree and granular tree based protocols. Thank you very much.